given to me is inhibition and activation. But I will briefly talk about chemistry classification and other things. Chemistry introduction. What are enzymes? Enzymes are biological catalysts. They speed up the rate of the biochemical reaction. This is a shape of an enzyme. I would like to mention this globular protein world. Enzymes are globular protein, maybe tertiary or quaternary structure. Some special RNA species also act as enzyme and are called ribozymes. Now, structure of enzyme composed of active sites and inactive sites. The active site of enzyme is the region that bends substrates, cofactor and prosthetic group and contain residue that helps to hold the substrates. The overall enzyme specificity and the function depend upon the active sites. Active sites generally occupy less than 5% of the total surface of the enzyme. Active site has a specific shape due to its specificity and it have a specific amino acid sequence. This active site have a specific amino acid sequence which is attached to the substrate. A change in the shape of protein affects the shape of active site and function of the enzymes. Now, active site can be further divided into bending site and catalytic site. Bending site is that site to which substrates attach. Catalytic site have some portion of the active site which helps in catalyzing the reaction. What are cofactor? Cofactor is the non-protein molecule which carries out chemical reaction that cannot be performed by standard 20 amino acid. So cofactor is essential for a reaction to be done. There are two types of cofactor, organic and inorganic. This is enzyme. For example, this is enzyme which is inactive. Without cofactor, it is inactive. On attachment of cofactor to that inactive protein, it becomes active and the result it becomes active. Now it can do its job. By attaching substrate, it can form enzyme substrate complex and then enzyme substrate complex change into its product. Inorganic cofactor, these are the inorganic molecule required for the proper activity of the enzyme. For example, please mention this one, this zinc. Zinc is a cofactor. Please remember this point. Zinc, a cofactor for which enzyme? Carbonic anhydrase enzyme. And magnesium has a cofactor for which enzyme? Hexokinase enzyme, which is which is working in glycolysis. So remember these 2 points. Organic cofactor, these are the organic molecule required for the proper activity of the enzymes. For example, glycogen phosphorylase requires the small organic molecule pyridoxal phosphate. Types of organic cofactor, which is a prosthetic group and coenzyme. Prosthetic group is a tightly bound organic cofactor, e.g. flavins, heme groups and biotin. These 4 are prosthetic group organic cofactor. And what is coenzyme? A coenzyme is loosely bound organic cofactor, e.g. NAD+, which is working in various reaction and biochemistry metabolism. An enzyme with its cofactor removed is designated as apoenzyme. Please remember this. Enzymes, when a cofactor is detached from its enzyme portion, then that enzyme portion is called apoenzyme. When the the complete complex of a protein with unnecessary small organic molecules like metal ions and other components is termed as holoenzymes or holoproteins. So what is the difference between holoenzyme and apoenzyme? Holoenzyme is the combination of enzyme and its cofactor, and enzyme without its cofactor as apoenzyme. Substrate. The reaction and biochemical reaction is termed as the reactant. When a substrate binds to an enzyme, it forms enzyme substrate complex. Site of enzyme synthesis. Enzymes are synthesized by ribosome, which are attached to the rough endoplasmic reticulum. Information for the synthesis of enzyme is carried by DNA through a process of, which is already told, by a process of transcription and translation. Amino acids are bonded together to form specific enzyme according to DNA codes. This is endoplasmic reticulum. This is ribosome, which help in enzyme preparation. Now, intracellular and extracellular enzyme. Intracellular enzymes are synthesized and retained in the cell for the use of cell itself. They are found in the cytoplasm, nucleus, mitochondria, and chloroplast. The example of intracellular enzyme are oxidative reductase, which which work through in a biological oxidation process, and enzyme involved in reduction in the mitochondria. Some are extracellular enzymes, which are synthesized in the cell, but they are secreted and they work outside the cell. Example are digestive enzyme produced by pancreas, which is lipase, etc., and are not used in the cell in the pancreas, but they are transported to the duodenum to help in digestion of various foods particle. Characteristics of enzyme, you already know which enzyme, the main characteristic is to speed up the reaction, and the presence of enzyme does not affect the nature and property of end product. The enzyme are highly specific in their action because each enzyme have their own active site, and their own active site have a separate amino acid sequence, and these amino acid sequence help in and it specifies the specificity of an enzyme active site. Small amount of enzyme can accelerate chemical reaction. Enzymes are sensitive, as you know, it is sensitive to change in pH and temperature and substrate concentration. Turnover number is defined as the number of substrate molecule transformed per minute by one enzyme molecule. For example, catalase turnover number is 6 multiplied by 106 per minute. Without catalase, the reaction will held by 6 times, and with catalase presence, it is multiplied by 106. So the enzyme speed of the reaction by 106 factor per minute. Nomenclature of enzyme. An enzyme is named according to the name of the substrates it catalyzes. For example, pepsin, trypsin, and renin. By adding suffix ase at the end of the name of the substrate, enzyme are named. Maltose, at OSE place we add ASE. So maltase is an enzyme which converts maltose to glucose and galactose. This is just name of various enzymes which works. Lactase works on lactose, maltase works on maltose, Cellulase works on cellulose, lipase works on lipids, amylase works on starch, protease works on protein. Of classification of enzyme, there are major six classes. There are six major classes. Each classes is further divided into subclasses into further divided in their subclasses. So a huge number of different enzymes are present. We will see in the next slide. For example, these are enzyme classes. Oxidoreductase are enzymes which help in reduction oxidation reaction. Example are lactate dehydrogenases. Please remember, lactate dehydrogenases are related to oxidoreductases. For example, hexokinases or transferases are belongs to transferases class. And each and every enzyme have its different role in various metabolic pathway. For example, triose phosphate isomerase work in isomerization, and it belongs to class isomerases. Ligases, RNA polymerase is belonging to enzyme class ligases. Mechanism of action. Various theories are being proposed according to the mechanism of action of enzyme. The catalytic efficiency of enzymes is classified by two perspectives: thermodynamic changes in processes at the active sites. If you see the reactants, the energy, free energy of the reactants in the products. Now, this is the transition state of uncatalyzed reaction, and this is the transition state of catalyzed reaction. You see this difference. This is due to the presence of an enzyme. So the enzyme reduce the free energy, reduce the transition state energy of a reaction. This is the difference, the energy gradient difference by which reactant is converted to its product. And if we add catalyst, the energy difference is reduced. Simple equation there. Thermodynamic, only a few substance crosses the activation barrier and changes into product. That is why rate of uncatalyzed reaction is much low. Enzymes provide an alternate pathway for conversion of substrates into products. Enzymes accelerate reaction rates by forming transitional state having a low activation energy. This transitional state have a low activation energy as compared to the uncatalyzed transitional state. So the speed of the reaction, they help to convert more reaction to more products by low energy. This is a property of an enzyme. Turnover rate, Sarah Khan is asking about turnover rate. Turnover rate means that without enzyme, a substrate is converted into its product, for example, 5 times. And each reaction have its own interior property to convert into product. By adding an enzyme, the turnover of that substrates, that how much that substrate is converted to its product. That is simple, the turnover meaning. By adding enzyme, the turnover of the substrate is how much increased to make its product. The total energy of the system remains the same and equilibrium state is not disturbed. Now, lock and key model, as you know, proposed by Emil Fisher, lock and key hypothesis, assume you already know this. There is no change in the active site before and after chemical reaction. The other model is induced fit model. The other model is induced fit model. More recent studies have revealed that this process is much more likely to involve an induced fit model. According to this, exposure of an enzyme to substrate causing a change. Now, if you see this is an enzyme, this is various substrates. According to these substrates, this enzyme change has active site. Now, this is an substrate. This will change the active site like this. Now, after the reaction, the enzyme reduces its previous stages. After the reaction, when the reaction is being catalyzed, the enzyme comes back to its original position. So this is induced fit model. This is substrate active site. Now, enzyme kinetics, you will it will be taught by Dr. Salman tomorrow, but anyhow, we will briefly go through it. Enzyme presence does not affect the nature and properties of end product. Yes, Fawad Ahmad, you you are you are right. You are asking, but a question, but your question is right because if you add an enzyme, it just speed up the reaction. It does not change the nature of the product. For example, when you add A plus B, it will give AB. If you add enzyme to A plus B reaction, it will not change AB to CD or ED. It will just speed up the reaction. Now, these are various kinetics means that by adding enzyme to a substrate, it converts to enzyme substrate complex and then into a product by which reaction these processes are going. These are simply known as kinetics. Kinetics analysis reveals the number and order of the individual steps by which enzyme transforms substrates into products. Studying of an enzyme kinetic in this way can reveal the catalytic mechanism of that enzyme, its role in metabolism, how its activity is controlled, and how a drug or an agonist might inhibit the enzyme. For example, activation energy, the least amount of energy needed for a reaction to take place. Enzyme acts on a substrate in such a way that they lower the activation energy by changing the route of the reaction. The reduction of activation energy increases the amount of reactant molecules that achieve a sufficient level of energy so that they reach the activation energy and form the product. By adding an enzyme, the activation energy is reduces. By adding an enzyme, the activation energy of a reaction is decreases. So more reactant is converted to product by low energy. For example, carbonic anhydrase catalyze the hydration of carbon dioxide. This much carbon dioxide per second, which is 10 this much faster than spontaneous hydration. Now, this is the initial energy state of a substrate, which to be converted to the product. If you see the substrate energy is higher as compared to the product, there is a phenomena that the diffusion world, if you use here, will be not bad. That high energy state is converted into low energy state. Mm, So uh, this, if you see this line, this is with adding catalyst, with adding an enzyme, which speed up the reaction, but it does not change the nature of the product. By this mechanism, the product will be same. By this mechanism, the product will be same. Just the amount is affected, not the nature of the product is affected, just the amount is affected. So this is the difference where we add catalyst, how much energy we can save here. Enzyme, it is an increase in the rate of reaction with the help of enzyme. Catalysis by enzyme that proceed via unique reaction mechanism typically occur when the transition state from a covalent bond. These are all old statements, you know. During the process of catalysis, enzyme always emerge unchanged. At the end of the reaction, these enzyme which work as a catalyst are unchanged. Please remember this. Enzymes don't change its shape while taking place in a reaction. Now, which are there are various factors which affect the enzyme reaction. Uh, the most important one is temperature and pH level, acidosis or alkalosis, which disturb the enzymatic activity. And up to some level, substrate concentration is also affecting the rate of enzyme reaction. Raising the temperature, you know, we can double the we can double the speed of the reaction by the presence of enzyme, which is Q10 is equal to 2 bar. Most biological process we take is by increasing 10 degrees C, we can speed the reaction up to double. However, sometimes heat energy can also increase kinetic energy to the point that exceed the energy barrier, which result in denaturation of enzyme. Please remember this line. Up to some level, by increasing temperature, we can speed the reaction in the presence of an enzyme. Beyond that level, we cannot speed that reaction. We can denature the enzyme level. We can denature the enzyme level. This is constant. Q10 is constant for each and every enzymes. But we take, for most biological process, we take as 10 degrees C. This is not always same for each enzyme. Some enzyme can double its activity by increasing 5 degrees C. Some enzyme can increase its activity to double by 7 degrees C. So this is for more biological constant we take as 2. We can double. Now you see the rate of reaction with relation with the increase in temperature up to some level. If you see the graph, up to some level, we can increase the enzyme reaction. We can increase the reaction in the forward direction, but beyond 40 degrees C, this enzyme is denatured and it declines the forward reaction to be go. So in between 5 and 40 degrees C, the enzyme activity is increases. After 40 degrees C, it decreases. This is not for every enzyme. It depends upon the temperature level is different for each and every enzyme. This is just simple concept that beyond that temperature, the enzyme is denatured. Now the effect of pH is very important in catalyzing various reactions in our body. Uh, most of the enzyme works at a pH between in a range of 5 to 10. 5 to 10. Most of the enzymes work in a range of 5 to 10. At which enzyme, Hamza Amin asking at which at which temperature the enzyme is completely inactive. Uh, it depends upon that which enzyme is working. It is different for each. The temperature mm, the temperature is different for each enzyme. For example, pepsine is denatured at 40 degrees C and chymotrypsin is denatured at 30 degrees C. So it is different for each enzyme. It have no, it is not uh, have a, what I would like to say, it is not the हर यो enzyme the para different like a temperature पकार दी different temperature د هر یو انزایم د لپاره پکار دی چې د خپل ریاکشن ډبل کی دغه شان د ډینیچریشن د لپاره هم ډیفرنٹ ټمپریچر پکار دی د هر یو د ټول انزایم د لپاره دا یو شان نشي کېدای ٹھیک شو نو دا په بوک کې شته د هر یو انزایم د لپاره چې کم ټمپریچر پکار دی په کم د ډینیچر کیږي and it does not work further. Please remember that. Now the effect of the pH, the optimum pH is between 5 and 10, almost 10. Below 5, it is acidosis, and above 11, 12, this area is alkaline. So by increasing pH or decreasing pH, the enzyme activity is disturbed. Now, if you see the pH affect the formation of now the pH for pepsine is round about 1 point something, round about 2. It works at pH of 2, the pepsine works at fix. Now it is trypsin work at a pH of almost 7 and arginase work at a pH of almost 9. So the pH level is also different for each enzyme, just like the temperature difference. Yes, 1 point. Some book, Javier Riaz, in some book pepsine have pH value of 1.4 and in some book it is almost 2. So you have to choose the value which is near to 2. They will give you option either 1.5 or they will give you option either 2.5. So 2.5 no, 3.5 or 3. So you have to choose the level which is near to 2. Yes. Now this is Michaelis mental model. Enzyme is attached to substrate by K1. This K1 is this K1 and by the reaction by which enzyme substrate is further catalyzed to metabolize to enzyme and product. This is denoted by K2 and ضروري نه ده چې enzyme substrate یو بل سره یو ځای او enzyme substrate complex جوړ کړي او دا ټول کنورټ شي enzyme ته او product ته دا ضروري نه ده څه enzyme او substrate واپس هم راځي enzyme او substrate ته product ته باندې کنورټ کیږي ځکه چې مونږ وایو چې وس فار ایگزامپل مونږ سره 10 enzymes دي او مونږ substrate add کو 20 نو دا 10 enzymes but 10 substrate سره active site باندې attach شي او 10 substrate به موږ سره پاتې شي نو دا 10 substrate چې پاتې شي نو دا خو کار نه کوي کنه ټیک شو نو دا ضروري نه ده چې enzyme substrate به ټول کنورټ کیږي enzyme product ته دا به واپس هم راتلی شي نو دا reaction is denoted by K1, this is by K2 and this is by K minus 1. This equation Km, this equation K minus 1 plus K2 divided by K1 is denoted by Km, which is Michaelis constant. This is simple. Remember that how it is derived. It is very long topic, and it is related to biochemistry. Just you remember the Michaelis equation like this. Ratawala goipande bandi that V naught, the initial reaction of the velocity, is equal to V max, which is the maximum velocity, and divided by Km, which is constant of Michaelis constants, and it is derived by these equation K1, K2, and K minus 1, and subtract. Please remember this one, and it is enough for you. Don't need to go in detail of this. Now, if you increase the enzyme concentration in the presence of a specific without increasing the amount of substrate concentration, the reaction goes in a goes like a straight line. It will increases, the reaction rate increases linearly, but without constant enzyme, but without increase in enzyme concentration, and you add substrate concentration more and more in the presence of constant enzyme concentration, the reaction will not increases like this. Up to some level, by increasing substrate, you can increase the reaction rate. Beyond that level, if you increase the substrate level, the reaction will not increases that much because of saturation of enzyme. Active site becomes saturated due to high amount of substrate, and further increase and reaction rate does not occur. This is what Michaelis-Menten plots. Remember this one. By increasing substrate concentration up to some level, we can initially increase the reaction rate. For example, this is the Vmax is the high amount of enzyme activity by which it can do, and half Vmax is the 50% of enzyme activity here. It is denoted, Km is denoted here, and it's same to the half Vmax of that enzyme. You can read it in your book. Don't need to go into the detail of these topic. Just remember this formula, please. Now, pharmaceutical enzymes are very virtually involved in all physiological processes, which makes them target of choice for drugs. Enzyme kinetic thus play a critical role in drug discovery as well, elaborating the mode of drugs. This slide already we have discussed that optimum temperature in which the enzyme best work is 5 to 9 or 5 to 10. Beyond these level, the enzyme activity is disturbed. Enzymes are most active in optimum temperature, usually at 37 degrees C. Now, pH are most active at optimum pressure. Enzymes are most active at optimum pH. Enzyme contain functional group, which is denoted by R group, which have specific amino acid sequence. By changing pH of the medium, these active site and R group are denatured, or it does not work properly at that pH. Now, if you see a substrate concentration increase the rate of reaction up to some level. Beyond that level, it does not increase the rate of reaction because of saturation of various enzymes. Yes, Junaid Alam. R group is a functional group of each enzyme. Some enzyme have CH3 is a functional group. Some enzyme have CH3 plus CH2 is a functional group. Junaid Alam, you are right. Just remember the basic equation. Don't go into the detail. R group means functional group. Each enzyme have its own functional group. Each enzyme have its own active site, and regarding that active site, each enzyme have its own R group. Now, inhibition. The prevention of an enzyme process is a result of interaction of inhibitor with the enzyme. These are substrate and inhibitor. Now it will, you will see in the next slide that either it will competitively inhibit this or non-competitively inhibit this. Types of inhibition are reversible or irreversible. Irreversible have no further classification. Reversible is further classified into competitive, uncompetitive, mixed, and non-competitive. Okay, now this reversible inhibitor is further classified into this. Now reversible inhibitor, there are 4 types: competitive, uncompetitive, mixed, and non-competitive. Competitive inhibitor, in this type of inhibition, the inhibitor competes with the substrate for their active sites. Formation of enzyme substrate complex is reduced while a new enzyme inhibitor complex is formed. For example, please remember this drug, statin drug, which help in reducing cholesterol level, and we give it to a patient who have history of myocardial infarction and who have history of high lipid profile. This statin drug is competitive inhibitor of HMG coenzyme reductase. This is an enzyme which work in synthesis of cholesterol. You will inshallah read it in second year, that how cholesterol is synthesized. Statin drug is an example of competitive inhibitor of HMG coenzyme reductase. Please remember this and this only. Uncompetitive inhibitor, in this type of inhibitor does not compete with the substrate for the active site of enzyme. Instead, it binds to another site known as allosteric site. This is allosteric site, then an inhibitor molecule attached to the allosteric site, and in combination, the substrate enzyme complex is not properly formed, and it does not help to convert the substrate into the product. Example of uncompetitive inhibitor are when you treat methanol and ethylene poisoning by giving what drugs, which are their drugs which are used in treating a poisoning of methanol is an example of uncompetitive inhibitor. I think the drug name is flumazenil. زما خیال ما نه خو فارما کې داسې خاص د دې ډرګ استعمال زموږ په سیټ اپ کې نشته، خو فلومیزینل ټایپ څه ډرګ دی که څه دي هغه موږ یوز کوو د میتانول ایتاینیل پویزنینګ دپاره او اټ ورک ایز ا انکمپیټیټیو انهبیټر. تاسو بیا وګورئ چې دا کوم ډرګ دی. The other example is tetramethylene sulfoxide and 3-butyl thiolene 1 oxide are uncompetitive inhibitor of liver is alcohol dehydrogenases. Mixed inhibition. In this type of inhibition, both enzyme inhibitor and enzyme substrate inhibitor complexes are formed. Both complexes are catalytically inactive. Non-competitive uncompetitive requires that an enzyme substrate complex must be formed. Uncompetitive inhibitor के allosteric site यार allosteric site but uncompetitive it will not compete for the substrate to attach to this active site. It will attach to a separate site on an enzyme. So it is uncompetitive. It does not compete with this substrate to attach to this site. So this is allosteric site چې په کوم ځای کې هم تاسو انزایم ولید او الستریک سایت او it will give an example of uncompetitive inhibitor simple lab دغه پکې څه نشته کانسپټ پکې نشته non reversible inhibitor irreversible inhibitor. This type of inhibition involves the covalent attachment of the inhibitor to the enzyme. The catalytic activity of enzyme is completely lost. It can also be restored only by synthesizing molecule. This is enzyme, which is CH2OH. Active site of enzyme is CH2OH. It will attach to the irreversible inhibitor by attachment. This is irreversible inhibitor. By attachment of this irreversible inhibitor, the configuration of the active site is disturbed. It changed to CH2O, and the active site of enzyme which work here is CH2OH. So the whole configuration of the active site is disturbed. It changes. So this enzyme will not work properly. And the example of this irreversible inhibitor is, I have prepared one MCQs that pysostigmine you will read you will see in the next lecture, inshallah. I have prepared one MCQs regarding irreversible inhibition. Example of irreversible inhibition are aspirin, which targets and covalently modified a key enzyme involved in proliferation as an irreversible inhibitor. Aspirin work as irreversible inhibitor by inhibiting the enzyme like cyclooxygenase and lipoxygenase, which work in processing inflammatory process. Now, the other word used here is suicide inhibition. It is an unusual type of irreversible inhibition where the enzyme converts the inhibitor into a reactive form and its active site. Just remember this word, don't need. تاسو دا MC چې کوم کوېسچن یې کنه پلیز تاسو ماته دغه کوئ په چیټ کې لیکئ او پلیز خپل ډسکشن مه کوئ کنه زه بیا بار بار چیټ ته ګورم او ډسټربنس پیدا کیږي پلیز چې څه کوېسچن یې هغه بس تاسو دغه کوئ که څه به کې مس شي انشاءالله بیا تاسو ماته مانه تپوسلی شئ زه به تاسو کلیر کوم ټیک شو او تاسو چې بار بار ماته هلته نوټیفیکیشن راځي چې چیټ نو زه ګورم نو بیا ټایم هم ضایع کیږي او دغه هم کیږي ښه نو تاسو خفه کیږئ مه ښه activation به اوس څنګه کوو activation is defined as the conversion of an inactive form of an enzyme to active form which is processed to a metabolic activity. مونږ ویو چې activation لپاره it needs cofactor. For example مونږ چې څنګه وی magnesium is working as a cofactor for various enzyme, zinc is a cofactor for various enzyme. Oh, please remember that sentences. Many enzymes are activated by cofactor and it is needed to work for an enzyme to to take place in a metabolic pathway. DNA polymerase is a whole enzyme that catalyzes the polymerization of deoxyribonucleotide in a DNA strand, and it uses magnesium ion Mg2+. Please remember this word. DNA polymerase work in the presence of which of the following cofactor? Magnesium, zinc, calcium, and whatever they made an MCQ from here. So you can take the magnesium ion. Horse liver dehydrogenase, for example, use zinc ion for its activation. Now, the diagnostic significance of enzyme. Now, lactate dehydrogenase enzyme, which is further classified into various types, lactate dehydrogenase 1, 2, 3, 4, and 5. But you have to remember that in which disease it increases, like myocardial infarction, myopathy, and muscle disorder, also in leukemias, acute hepatitis, and carcinomatosis. Simple like that, transaminase enzyme AST and ALT increases. AST, aspartate transaminase or serum glutamyl oxaloacetate increases in myocardial infarction. Alanine transaminase and SGPT as increases in liver disorders. If you see a patient have a suspicion of liver disorder, you are going to advise ALT or SGPT. Creatinine phosphokinase is increased in myocardial infarction, but this CPK have further three types, mainly three types, which is CPK MB, CPK MM, and CPK BB. And regarding that further classification of CPK, myocardial muscle have CPK MM and CPK MB, and myopathy have only CPK MM, and brain have only CPK BB. So remember these further types you will see in your book. Alkaline phosphatase is increased in bone disorder, obstructive jaundice, and hyperparathyroidism. Please remember acid phosphatase and increase in prostatic carcinoma. These are various enzymes and have diagnostic significance. Isocitrate dehydrogenase is raised in our body due to brain tumor and meningitis, and also due to liver disease. Amylase is secreted by our salivary gland like parotid gland, so it is increases in parotitis, inflammation of the parotid gland. Also amylase is secreted from pancreas, so it is also increases in inflammation of the pancreas. Also diabetes, intestinal lipase is increases as pancreatitis or carcinoma of the pancreas. Gamma glutamyl transpeptidase is increases due to liver damage, and it is indicator of alcoholism. Those people which are going to drink more and more, their GT level will be increases. So remember this one. Isoenzyme. What are isoenzyme? We have already, isoenzyme are further classified. For example, LDH have further various isoenzyme like LDH1, LDH2, 3, 4, and 5. LDH1 is present in myocardium, RBC, and kidney. LDH2 is also present in myocardium, RBC, kidney. LDH3 is present in brain. Please remember these specific LDH3 for brain. They can make an MCQs on this. They will give you option that brain contain which type of isoenzyme of LDH, LDH1, 2, 3, or 4. So please remember. And it is elevated in leukemia and malignancy. LDH4 is present in lung and spleen. LDH5 is present in skeletal muscle and livers. The whole presentation is being prepared from these various books, including Living Card, including some other Indian books. you have any question regarding the current topic, which is the enzyme topic is very simple, and the MCQs which come from the enzyme topic is very simple, and it have no deep concept. So I have prepared 20 MCQs, inshallah, and the next lecture, we will just read that 20 MCQs and you will give me answer of that 20 MCQs. We will just discuss that 20 MCQs, inshallah. If you have any question, you can ask. Apo enzyme, Sarah Rahman says the apo enzyme and holoenzyme. Apo enzyme is an enzyme portion without its cofactor, and holoenzyme is an enzyme with cofactor. Enzyme plus cofactor is holoenzyme. Enzyme without its cofactor is apoenzyme. Shima Gul, prostate carcinoma. Yes, prostate carcinoma is very is a disease in old age, or in which we can check the acid phosphatase level of that patient. If it is increases, we can suspect, and we can do thinking about that the patient have prostate carcinoma. Yes. Non-competitive, uncompetitive. Yes, Qurratulan, you are right. Uncompetitive and non-competitive are same. Feedback inhibition. Feedback inhibition څه ته وایي؟ ګوره چې یو ریاکشن دی، فار ایگزامپل موږ سره د تایراید ګلینډ نه څه دغه کیږي، تایرکزین ریلیکس کیږي. تایرکزین چې ریلیز شي نو ټي اس ایچ د ټي 3 ټي 4 موږ سره سیوا شي. when T3 and T4 are increases, it goes back to the blood, to the pituitary gland. او الته مونږ سره د هغې ریسپټر یو الته مونږ ته سینسر لګېدلی، او مونږ ته وایي چې لکه T3 T4 سیوا دي، نو پیچوټري ګلینډ ته وایي چې تا تایراید ټي اس ایچ مه ریلیز کوه چې هغه سیګنل ورکوي تایراید ته. سمپل فیډبیک انهبیشن څه دي؟ دغه یو اگزامپل دی. Suicide inhibition is also a term used. For example, like یو ډرګ دی، یو سبسټانس دی، ا سبسټانس دی، هغه ځي او د څه سره انزایم سره ونښلي، د بي انزایم سره ونښلي. نو هغه داسې وکړي چې یو خو ایرریورسیبل انهبیشن دی، هغې کې خدای چې د بي انزایم سره د دې اکټیو سایټ اکوپای کړي او دا اکټیو سایټ بالکل لکه ډیمیج کړي، فردر دی بیا دغه نشي کولی، ریاکشن نشي کولی. سوسایډ انهبیشن دا دی چې د ا سبسټانس لاړ چې بي انزایم ته ونښلي، او دا بي انزایم د ځان سره بالکل بریک ډاون کی، او بالکل د اکټیو سایټ او د نور سایټس ورله هم دغه کی ډسټرای کی، جست سوسایډ بالکل ختم. Yes, thermolabile means that it is influenced by temperature. Enzymes which are influenced by temperature. Next. This is asan question چې د conceptual question وکړي یار دا تاسو. Okay, inshallah next class I will discuss 20 MCQs which I have made regarding enzyme. Inshallah on Wednesday.